Okay, I want to talk to you about section 4.3, some of the sample homework problems. We're talking about how to convert between log form and exponential form. That's sort of the main, one of the main themes of this section. So we want to be able to think about the two forms. Let me do an easy example before we jump into these that might not be as obvious to us. I feel like we all know that 5 to the second equals 25. And when we do that, we think of that as doing an exponent. 5 to the second, 2 being the exponent, so an exponential form equals 25. So when we say 5 squared equals what, we consider that sort of doing an exponent. That's an exponent. When we say 5 to what power equals 25, when we're looking for the exponent needed to make this work, that's doing a log. Instead of writing it in this form, though, which maybe you're thinking, why couldn't we just do that? I don't know. We just don't. But we could write it like that. That would be the idea of a log. Really, that's what it all boils down to. We're saying 5 to what power equals 25. That is what a log is. But instead of writing it that way, we have this other way of writing it. We write that log subscript, so with base 5 of 25 equals what? The answer to a log is an exponent, and that's the chant you need to kind of have in your head, is the answer to a log is the exponent needed to make this happen. So whenever we write it like this, again, this is the base of the log. We call this the argument of the log, what it needs to equal after the exponent. So 5 to what power is 25? And this one comes out nice and even for us, so we're able to kind of do this one without a calculator. 5 to what power equals 25? And so we know that to be 2. So we'd say the answer to that is 2. And that's how we start out on your homework. This question that I have for you, it asks you a series of log questions with various bases that you can do without a calculator. Now, you can't always do these without a calculator. So there'll be some, like if this was log base 5 of 20 equals what? It doesn't come out even, and I will need to use my calculator, and there's a way we can do that on our calculator later. But for now, we can do it without a calculator, although if you want to use your calculator, feel free. But these are even nice answers. So it's saying 2 to what power is 16? So 2 times 2 is 4, 4 times 2 more is 8, and then 8 times 2 more is 16. So you have to multiply 2 times itself 4 times. And check it out, 2 to the 4th equals 16. Okay, this next one is saying 3 to what power is 1? And so any base with a 1 right there, the answer is going to be 0, because any base to the 0 power equals 1. Check that out. Again, I like for you to prove this kind of to yourself. It helps you get it right in your mind. If you'll type it on your calculator and see it for yourself, type 3 raised to the 0, and really anything raised to the 0, and you'll get a 1. That is a rule. All right, so anytime you see any base log with 1 there, the answer is always 0. Next one, 10 to what power is 0.1? Now that one might not be so obvious. I think that's kind of confusing. Let's see how I can write that. 0.1, another way of seeing it, I think it would be better to write 0.1 is 1/10. You know, if you read that like it's written, the 0.1, one place back, that's the 10th place. So this is like saying 1/10. Right? So 10 to what power makes it 1/10. So we're going to use this. It's going to come up again in this section. I'm not sure we've used this in a while, but when you take a base to a negative exponent, it puts it as a fraction. It moves it to the denominator, the base to the denominator. So this is 10 to the negative 1 would make the 10 show up in the denominator. All right? So again, negative powers is what makes our fractions. Our fraction base or our decimal bases, which are equivalent, like you can see. All right, next one. Again, kind of reviewing some old things. We may not have seen this in a while, so I wanted to help you think about these again. 2 to what power is square root of 2? So, might not have thought of this in a while, but square root of 2 is saying 2 to the 1/2 power. A square root is the same as a 1/2 power. You can always convert a radical to an exponential power by thinking of the root, what's in the little v, the index it's called, and normally we do a lot of square roots, but there's others. But if nothing is it's understood 2, a square root. So that's a 2, and then this is raised to the first power. So anytime you have a radical, convert it to an exponent. You take power, which should be 1 here, and the index, and it's 1/2. And so whatever the base is, 2, and a lot of 2's here, 2 to the 1/2 power. So we're saying 2 to what power makes 2 to the half power. So that is kind of done for us there in that form. It would take a 1/2 power. 2 raised to the half is the same thing as square root of 2. Next, e to what power is this arguments. Remember, to take it out of log form, we can say e to what power equals this argument. Let me get this stuff out of your way. All right, so it's in the denominator now. So we talked about how that makes a negative exponent. So it's going to be negative, and it's 2. So we would say that x has to be the -2 power. To turn it upside down, sort of make it a fraction and get the 2. That power is 2 and negative. Next, it's saying 1/2 to what power equals 8. You might know that it takes 2 to the third to get to 8 because it's upside down from this, though it's a negative. Again, if they're a fraction to a whole number, there's been a negative power involved to make that flip. Other ways to think about this, so we know x is -3 is going to be my answer there. Again, because 2 to the third makes 8, and because it's upside down, the negative had to be there. Another way to do this would be flip this fraction and make that a 2, which will change the power to negative, and then make 8 2 to the third. And then if you can get like bases, we did this in the last section, if you can make like bases, then you can set the exponents equal to solve. That's also another way of knowing it's -3. All right, so actually question 1 was kind of meaty there. It kind of gets to the heart of things we're going to do. So don't let that worry you, because that was kind of a hard startup. Okay, question number 2 I've got here. It's just 1. You just had to do 6 in 1 there. So this one is just convert this. Now practice converting between log form to exponential form. Then we're going to practice it the other way in number 3. All right, so practicing what we just did, we know that this log base 3 raised to the second equals 9. So you'll write that in your boxes, just showing how you know to convert that between log form of our exponent. Now you might remember on the exponent graph, the pivotal point was at 0, 1. It went through this little point and the curve went up this way. In the log graph, that should be all reversed. The inverse functions flip about the line y equals x. So it's flipped over here. Let me show you. Here's the exponential graph, like an a to the x power. If it was written like that, and the pivotal point was 0, 1. So when we do a graph, it should be the inverse of that. This example log, say that's base A, so any base log, it's going to be down here instead. Same old curve, but instead of going through 0, 1, the inverse switches the x and y points to 1, 0 as the pivotal point. Now, let me show you how you can get that, derive it if you wanted to make a t-table, because I always like the t-table idea, being able to point plot your own points to find your graph that way. So what are the solutions to this? How could you find some solutions? So let's say I try plugging in 0. Put in 0 for x, as in a t-table. I would do y equals log base 3, 0. Now, how do we do that on our calculator? What it's really saying from our exercise above is 3 to what power equals 0. Again, 3 to what power, the exponent is the answer. 3 to what power is 0. So 3 to the first, no, that 3 to the first would be 3. 3 to the second, 3 to the third. You know, that doesn't seem to be working. What about 3 to the 0? That would be my most educated guess, I guess. 3 to the 0, if you type that on your calculator, is 1. Anything to the 0 is 1. So that's not it. What about negative numbers or fractions? You can try type away. 3 raised to what power would equal 0, and nothing is going to work. There is no answer to that. And that's actually because x equals 0 is the asymptote. So that's going to be, and you can kind of see it from this standard graph here, it's not touching along the line x equals 0. In the exponential graph, it was y equals 0. So, you know, everything's in reverse from exponential to log. It's the inverse function. So anyway, that is definitely going to be an asymptote for us. So I can't plug in 0. What's another way to know that if you were trying to do it on your calculator? This may not have come up in your homework or notes section yet, but if you don't have a subscript button in your calculator, and don't worry if you don't, most calculators do not, the way that we can do that is take the log of 0 divided by the log of 3, called the change of base log. Anytime we're doing a base other than base 10 logs, you can do directly on your calculator with the log button, common log, or if it's a E is the L calculator. So if it's not E or a T, you can't directly do that on your calculator. So either you have a subscript button, which like I said most don't, or you do this. This is kind of the standard way to fix this. You do the log of the argument divided by the log of the base. Again, that's called the change of base law. So let's type that in our calculator and see what happens. Okay, can you see this? I might need to turn my light on it. When I do log, and it can be a log LOG or an LN, it's actually any base log, this will work. So I'm going to do whichever one you feel like. Log 0 divided by log 3, error. You get that error type of message, domain error. You can't do that. All right, so that's out. Kind of figure that out. So forget that. Maybe try plugging in 1. So if we plug in 1, log base 3 of 1, you might know 3 to the 0 is 1. You might kind of think through it like our earlier exercise, or use this new trick I just showed you. Log 1 divided by log 3. Do that on your calculator, you also get 1, 0. So now we're starting to build some points, and you can point plot away. Plug in 2. If I do 2 for x, log base 3 of 2, I'll do log 2 divided by log 3. All right, that one's not going to come out so perfectly. So what do? We'll get a decimal of some sort, which they're not as pleasant to graph, but we can do that. 0.63, we can kind of estimate it. Over 2 is up 0.63, so a little under 1. And then we can plug in 3, log base 3, 3 for x. That's going to be 1. 3 to the first equals 3, or again, use your new trick I just showed you. Over 3 is up 1, and on you can keep going, and that sort of shows you this curve looks like that. To figure out what's happening in here, because it doesn't just start there, we could plug in fractions. I'm not sure that's our favorite thing to do. You could plug in a fraction and get a point, log base 3 of a half, and it's going to be somewhere down in here. and on to get closer and closer to that 0, and you can derive the shape if needed with point plotting.